Now let's discuss the fourth possible connection of star delta connection. On primary side, the connections are left unchanged for all the four possible connections, and the change here we are making on the secondary side winding connections. And in fourth case, what we are doing that we are taking the connections from non-dot ends and joining the dot end with non-dot end. Let's see that. So here we are joining the dot end with non-dot end, dot end with non-dot end, dot end with non-dot end, and taking the connections from non-dot ends. So this is the fourth possible connection of star delta connection. And now let's draw the phasor diagram for this. And primary side phasor diagram is same as that of all the previous three cases. And now we need to draw the phasor diagram for the secondary side winding connection, that is for LV winding connection. So secondary side phasor is drawn parallel to primary side phasor. So let's draw the secondary side VA phasor parallel to primary side VA phasor. And now let's decide the direction. On primary side, the connections are took from dot end, and on secondary side, connections are took from non-dot end. Means the secondary side VA phasor will be in opposite direction to primary side VA phasor. So like this. And now let's decide the terminals. So on secondary side, we took the connections from non-dot ends, and that is A1. So arrow will point towards the connection we took from. So arrow will point towards A1. So other end will be A2. Now let's draw the VB phasor. Drawing VB phasor parallel to primary side VB phasor like this. And now we need to decide the direction. And here the primary connections are took on dot ends, and secondary side connections are took from non-dot ends. Means the secondary side VB phasor direction will be opposite to primary side VB phasor. So like this. And now we need to decide the terminals. So here the connections are took from non-dot ends, that is B1. Therefore arrow will point towards the connection we took from, that is B1. So this is B2. Now observe in winding connection that A2 has connection with B1. Therefore here we will obtain B1. So place this phasor such that A2 will be having B1 connection. So like this. Therefore other end will be B2. Now let's draw the secondary side VC phasor. So let's draw the secondary side VC phasor parallel to primary side VC phasor. And now we need to decide the direction. So here on primary side we took the connection from dot end, and on secondary side connections are took from non-dot end. Means the secondary side VC phasor direction will be opposite to primary side VC phasor. So now the direction of secondary side VC phasor will be like this, opposite to primary side VC phasor. And now we need to decide the terminals. So here on secondary side connections are took on non-dot ends, and here the non-dot end is C1. Therefore phasor points towards the connection we took from. So arrow points towards C1. So obviously the other end will be C2. Now observe in winding connection that B2 has connection of C1. So therefore place this phasor as it is such that B2 is having connection of C1 and A1 is having connection of C2. And now we need to decide the phase to neutral voltage of delta connection. And we know that in delta connection there will be no neutral connection, but for comparison purpose we are taking the imaginary neutral. So here let that be small n. And now we need to decide the phase to neutral voltage of delta connection. So here the connections are took from A1. Therefore the phase to neutral voltage will be A1n. Now superimpose this diagram on this and observe the primary side phase to neutral voltage and secondary side phase to neutral voltage. Therefore the primary side phase to neutral voltage and secondary side phase to neutral voltage will look like this. In vector group symbol, the numerical will indicate the LV winding phase to neutral voltage phase displacement with respect to HV winding phase to neutral voltage. So here this is LV winding phase to neutral voltage, and this is HV winding phase to neutral voltage. Okay. And HV side phase to neutral voltage is represented with minutes needle in clock, and LV side phase to neutral voltage is represented with hours needle in clock, and the corresponding clock hour that is obtained is the numerical in vector group symbol. Therefore, place this diagram in clock such that primary side phase change voltage will point towards 12, because primary side phase change voltage is always taken as reference, so is why it is always shown pointing towards 12. And now if you place this diagram such that phase change voltage is pointing towards 12, then the diagram will look like this, and this represents the 7 o'clock. So now let's identify the vector group symbol. In vector group symbol, the first character is in capital letters, and that will represent the HV winding connection. Here we took HV winding as star, so the first character is represented in capital letter, and that will represent the winding connection, therefore capital Y. And now the second character in vector group symbol will indicate the LV winding connection, and that is represented in smaller case, so here delta, therefore small d. And for this connection we got the numerical as 7. The angle between minutes needle and hours needle here is, if you measure in clockwise direction, it will be 150 degrees, or you can write it as 180 degrees minus 30 degrees. Therefore, for this type of star delta connection, we are having a phase displacement of 150 degrees. Therefore, with star delta connection, we are obtaining the phase displacement of plus or minus 30 degrees and 180 degrees plus or minus 30 degrees. And this phase displacement always indicate the LV side phase to neutral voltage displacement with respect to HV side phase to neutral voltage, irrespective of what is primary and secondary. Now let me draw all the 4 possible connections of star delta connection, so that it will be easy for you to remember those connections. Let these 3 be the HV windings, and let these 3 be the LV windings, and let these be the dot end terminals. And we know that HV winding terminals are represented in caps, that is A2, B2 and C2. Therefore, these ends will be A1, B1 and C1, and LV winding terminals are represented in smaller case. So this is A2, B2 and C2. These ends will be A1, B1 and C1. And for all the 4 possible connections, we left the primary side winding connections as it is. So let's draw all 4 secondary side windings. Therefore, these are the dot ends. Therefore, this will be A1, A2, B1, B2, C1, C2. This will be A1, A2, B1, B2, C1, C2. This will be A1, A2, B1, B2, C1, C2. Here, for first 2 possible connections, we are taking the connections from dot ends. So extend these like this, so that it will be easier for you to say that these are the connections we are taking from. And for the 3rd and 4th possible connections, we are taking the connections from non-dot ends. So extend these non-dot ends like this. And now observe that here what we are doing means, in first case we are joining the non-dot end with dot end. So non-dot end with dot end and non-dot end with dot end. But for the second possible connection, what we are doing means, we are joining the dot end with non-dot end, dot end with non-dot end, and dot end with non-dot end. Here we join the non-dot end with dot end, and here we join dot end with non-dot end. So these are the first 2 possible connections of star delta. And now coming to this case, so here first join the non-dot end with dot end, non-dot end with dot end, and non-dot end with dot end. Okay, and for 4th possible connection, join the dot end with non-dot end, dot end with non-dot end, and dot end with non-dot end. And the primary side connection is star. And here what we are doing means, we are joining the non-dot ends together and taking the connections from dot ends. And this primary side connection is common to all the remaining 3 connections, and we are leaving that connection as it is without any changes, and the changes that you will observe only in secondary side winding connections. So these are the four possible connections of star delta connection. From each connection we will get different phase displacement. Now let's know the phase voltage ratio, which can be taken as equal to turns ratio, that is similar to that of single phase transformer, and which is represented with K. So that is equal to N2 by N1. Let small v2 be secondary side phase voltage and small v1 be primary side phase voltage, and here N2 represents the secondary side number of turns and N1 represents the primary side number of turns. So here phase voltage ratio can be taken as equal to small v2 by small v1. And now let's know the line voltage ratio. Let v2 be the secondary side line voltage and let v1 be the primary side line voltage. So v2 secondary line voltage and v1 primary line voltage. The secondary side connection is delta, therefore the relation between line voltage and phase voltage for delta connection is that line voltage is equal to phase voltage. So here line voltage v2 is v2 on secondary side and the phase voltage on secondary side v2 is small v2. Therefore this is one relation. And now observe the primary side connection. Okay, primary side connection is star. So the relation between the line voltage and phase voltage for star connection is that line voltage is equal to root 3 times phase voltage. So primary side line voltage we took v1, which is equal to root 3 times phase voltage. Primary side phase voltage is small v1. Therefore this is the other relation. Now in line voltage ratio, replace the line voltages with the phase voltages, that is equal to small v2 by root 3 times small v1, and we can take that 1 by root 3 into small v2 by small v1 can be taken as equal to K. That implies line voltage ratio is equal to v2 by v1 is equal to 1 by root 3 times K. That implies v2 is equal to v1 by root 3 into K. Now if you observe from this relation that secondary side voltage is less when compared with primary side voltage, that is it is 57.7% of primary side voltage. It means this type of connection is used for step down applications, and the advantages of this connection are that this connection is economical for large high voltage transformers, and the second advantage is as the primary is star connected, fewer turns are required. And here on primary there is star connection, so by providing neutral connection, distortion in output can be avoided. And here the other advantage is no third harmonic problem, as here this type of connection is having delta connection on secondary side, so there will be no third harmonic problem, and unbalanced load can be handled. So these are the advantages of this star delta connection. And now the disadvantage of this connection is that it can't be paralleled with other transformers having different phase displacement. which means that to operate transformers in parallel, all the transformers must have same phase displacement. And now the application is, from the line voltage relation, we seen that the secondary side voltage is less when compared with the primary side voltage, which means that this type of connection is employed for step down applications. Means here the application of star delta connection is on substation and to step down the voltage. This is about star delta connection.